Well, hello guys, it's Cliff here from Down Under. In this video, I'm going to take you along on a bit of an adventure into case hardening mild steel. I'm doing a series of experiments and finding out some very interesting information. Please stay tuned. So I welded up a little mild steel box out of 6mm plate with a flat surface. I'm hoping the lid just screwed on will seal it well enough to keep most of the gases in. Picked up some hardwood lump charcoal that I'm going to break into smaller pieces, and some sodium carbonate in the form of washing soda crystals from the supermarket. Apparently that acts as a catalyst and helps with the chemical reaction, producing the right gases inside the little steel box to help the carbon to penetrate more efficiently and deeply into the part. The little steel box is quite handy to catch the broken charcoal. I'm just using my drill press to smash it up. Done a bit of study online about the best size for the charcoal, and apparently about 8mm pieces are optimum. You can go up to a little bit bigger than that, but too small is not ideal and too big is not ideal. So we're just going to produce enough of those pieces of charcoal by this simple method of a little plunger in the drill press. Well, I'm getting tired of studying online. It's time for me to do some actual experiments and have a bit of fun with it. So I've mixed up my crushed charcoal with my sodium carbonate. It's supposed to be in the 2 to 10% range, just approximated it there, and put some into the box with some parts, another blade, a mild steel blade for my sheet metal folder, the finger there, a mild steel stud and some bits and pieces in there. I'll try partially covering it, and that way I'll learn a bit about how important the gas penetration is, whether it's covered or not. I'll put some bricks in there also to see how much I need, and heat it up to the temperature. I think it's about 720 odd degrees C. See how long it takes to penetrate in. Apparently it's about 0.1 of a millimeter for thou per hour. I can do some tests to see what the depth penetration is. Perhaps I'll do it for about 4 hours initially, maybe 5 hours, and see if that gives me 0.5 mil of case depth. It'll be interesting to see how I go. Well, this is just a little electric furnace I bought a couple of years ago. It's not really big enough to do a full range of work, but you know, they get quite expensive. But you don't have to buy an electric furnace. You could make one, or you could make a gas furnace just by getting some fire bricks and a gas torch. There's plenty of videos online showing you how to make those, and that would be a lot cheaper option. This is actually my second experiment with case hardening from the home workshop. First time I used a tin with a press-on lid, something like that. I'll have to warn you against doing that. That was not a good idea. I guess the charcoal and so on inside the can is flammable, and when it got to a certain temperature, I suppose with the oxygen and the heat, it ignited. Maybe that's what always happens anyway, I don't know. But anyway, the lid blew off with a big bang and did a bit of damage to my furnace, blew the little sealing plug out of there, and gave me a hell of a fright. So this box is a little bit more solid than that. There we are now, just starting to heat up. So I'll double check online again. I think it's 700 odd degrees C to get the best penetration, and then we'll leave it for 5 hours. So I'm just checking online the best hardness, and so I put it into the AI Copilot. What is the best temperature to carburize pack hardened mild steel? The best temperature, this is the reply for carburizing, is 930 degrees C to 955. Oh, I had that wrong. There's quite a bit of contradiction online with information about case hardening I have found. So I said, thanks, I've heard it was 725 degrees C. Can you check your data from other sources? I appreciate your diligence in checking the information based on multiple sources. The optimum temperature for carburizing mild steel is indeed around 950 degrees C. All right, I'll go and put the temperature up a bit higher in my workshop. So we're becoming more and more affected by AI. I don't know if I'll live long enough to get to the point where they supersede us human beings, but it's fascinating to watch. Well, that was interesting. So this is my first real attempt at case hardening, and it got so hot, the whole area got hot. The electrical control cabinet got hot sitting on top of it. So I thought that's going to melt down, so I moved it up there on a little shelf. And after about 4 hours, I had a wee peek inside, and oh my God, it was like white hot in there. And I thought, well, I just don't know whether this oven can handle that sort of heat. I forget now what it was rated to. I think it was rated to 1000 degrees C. Anyway, at 950 degrees C, after 4 hours, I lost my nerve and turned it off. Let it cool down overnight. It's still quite warm. I'll take it apart now and let you have a look inside. Well, I've just been struggling to get it apart. Now I know why people don't screw the lids on. They just oxidize so badly with that much heat. They gained about a whole size, the cap screw. I couldn't even fit the Allen key in. I had to get them off with vice grips, and one of them broke off. And then even when I got the cap screws out, the lid was sort of like welded on. I didn't use any sealing clay, but I had to really smack it here to get it loose. So it's almost like it's welded on. So maybe I don't need to use, you don't need to use sealing, any sealing clay if it's a close fit. So I put in these bits of, still quite hot, I put in these bits of tiling just to see if they could be used to fill up the gap. Now I know some of you are thinking, I don't have much charcoal in there, should be full of charcoal. Yes, but I wanted to find out, well, I won't know unless I put in a lesser amount just how important the volume of charcoal is. I won't know whether I don't seal it, just how important it is to seal it. So I've erred on the negative so that I can get useful information. These are quite hot, but I'll have a good look at these, and of course I won't know until I've tried hardening them, heating them up to the hardening temperature and quenching them, and then I can do some tests, for example with this part, to see how deep the case is. I've got different parts in here, ouch, and I can check them out and see just how good the surface hardening is. I'll get back to you on that, but quite pleased with the looks of it. It's not badly oxidized, so the lid or the charcoal has presumably sealed out enough oxygen for that side of it to work well. Just looking online again, here are some temperatures associated with case hardening. The carburizing temperature range is that scary, 880 to 960 degrees C. Maybe next time I'll try it at more like 900 and see if it works as well, and I'll avoid melting down my kiln. Case hardening temperature range is 780 to 820. So perhaps I'll set the oven at 800 for that now, tempering just to take the edge off the hardness and remove some of the stresses, 150 to 200 degrees C. You've got to be careful with artificial intelligence. Even if you're friendly, they might give you the wrong information. Here I've said, hi, mild steel that has already been pack carburized. What is the temperature? What temperature should it be heated to for quenching? And the reply was, for quenching pack carburized mild steel, the temperature should typically be around 925 to 950 degrees C. And I Googled it and got something different. So I said, if I Google it, I more often get case hardening. The temperature range for case hardening is 780 to 820 degrees C. And the reply was, you're right, I appreciate you pointing that out. The temperature range for case hardening mild steel is typically 780 to 820 degrees C. Thanks for catching that. Yikes, you've got to be a bit careful with artificial intelligence, guys. Well, it's been at 800 degrees now for half an hour, so that should have soaked into the bigger part. Not at all influenced by the fact that I have to drop Jan down at the garage. And I'm going to quench the bigger part in oil because it doesn't need to be glass hard, and then quench the smaller parts in brine. Oh, maybe I'll test it for hardness first. Alright, let's go. Don't fumble it. Into the oil. Close the door, move it around, get out of the way of the camera, don't breathe the smoke. Smells like a third world fish and chip shop here at the moment. Okay, so we're going to leave it in there until it's, going to close that door on the other parts or they'll go cold. So they've been at 800 degrees C for about half an hour. Now I need to get this down to at least 150 degrees C so that it doesn't temper with its own residual heat. Yelch, it's still a couple of hundred degrees C. But I'm conscious that the video is rolling, so don't let that influence the time in the oil. Fish and chips with some, this is canola oil, which I gather is quite a good cheap way of putting together some heat treatment oil. It's not too toxic and it can handle the heat quite well. This is probably why they cook fish and chips in it. Alright, so let's see whether or not that appears to have gone hard. So down the end where it was buried in the pack carburizing. Oh yeah, that's hard. Down the other end it was out of the charcoal. Still seems to be hard. So we're going to do some interesting tests on that. So yeah, that's really hard. So there's no need for me to now brine quench the other parts because that's unnecessarily severe. So I will just oil quench these parts now. They're in a little basket. Woohoo! Although case hardening is new to me, I've done a lot of hardening of tool steel over the years. This is starting to become more and more like hardening of tool steel now that the carbon is soaked into the steel. The next stage after quenching is to temper them, just to remove some of the stresses, but I don't want to lose too much of the hardness, so I've got to go out now. So to stop them from going cold, I've just put them on top of the door there, which is probably only about 50 or 100 degrees C, but that's so that you don't risk, you run a risk if it goes absolutely cold of inducing cracking into the surface before it's tempered. It's unlikely, but you know, it's a bit warmer on the door there, and when I get back I'll temper it to probably about 150 degrees C will be okay, and I can do some tests. But the parts look really nice, just not very oxidized and nice and black. Well, I've started doing some tests. So on this piece of steel, it's definitely originally a piece of black mild steel. I started bench grinding the end off it and scratch testing it with my scriber. Now it just wouldn't scratch it, and I ground more and more off and it just wouldn't scratch it even in the middle. It's 6 millimeters thick through its thickest portion, and after I'd ground off about 1 millimeter it was still really hard in the middle. So I put it in the vise and hit it with a hammer, and it just broke off like a piece of glass. If you look at the structure in the end of it, you can see it's hard right through. Well, that's really interesting, because in theory it should have only gone in 0.1 of a millimeter, 4 thou per hour, so that's 0.4 or 16 thou deep, but it's gone right through 6 millimeters thick. So I guess that's another myth. There's a lot of false information about heat treatment. Maybe that's because it goes back to the old days of blacksmithing, and it's been handed down over the generations, and it's got mixed up with a whole lot of old wives' tales. I don't know, but I know the tests that I've been doing so far have found quite a bit of variance with the information I'm getting online. So it sounds like heat treatment through pack carburizing with that catalyst of sodium carbonate penetrates a lot more quickly than I realized. So that's really useful, but of course now I don't know how long to leave it in for. Maybe 1 hour at a lower temperature would be adequate for case hardening in most situations. So I'm tempering these parts at 200 degrees C. You can see there they're just going brown in color. That should be relieving stresses without softening too much. Well, those parts are tempered now. You can see they're sort of brown in color. That's a hour or so at 200 degrees C, and most of the parts are still really hard, you know, about file hardness, around 60 Rockwell C. These are the parts that I didn't temper, that I broke. That's really glass hard. But the strange thing is, this folder blade or finger part has gone quite a bit softer. I mean, I can file it so it's down below 60 Rockwell C. It feels like somewhere between P20 steel and hard steel, maybe only 40 Rockwell C, something like that. So I was going to grind into it with the surface grinder to see how deep the case is in this part. I could do that on this part down the end that wasn't buried in the charcoal, and down the end that was buried in the charcoal, to see the depth of case. But I can't really do that now because it's been softened too much by the tempering process. I'm a bit mystified by that. 200 degrees C shouldn't really have softened it that much, but it seems to have in the case of this steel. Of course, I don't know the exact makeup of the steel, but it looks like I've got quite a bit to learn still about case hardening. These parts are still hard and have behaved as expected. This mild steel piece here has hardened right through. That surprises me. It's definitely mild steel, but why did it harden right through after only 4 hours? So I've got a few questions. This is my first real experience with case hardening, and I've obviously got a lot more to learn, but I will be using it more often now that I have a process established, and I should be able to gain knowledge and experience over time. I made some notes here about what I've learned, and just summarizing what's in this video. So I think next time I need to carburize at a lower temperature at the bottom end of the range, say 880 degrees C, for a shorter period, say 2 hours, in a part that doesn't matter if the case comes out very shallow, because there's a lot of applications where a shallow case is fine, and then I can test to see how hard it is and how deep the case is, and I'll get some more information. But I got a whole heap of really interesting information from these tests. So this time I'm not going to heat it as hot. It takes about, at least an hour to get it up to temperature. Ooh. And maybe at that lower temperature of 880, it will not oxidize the box as bad. It'll be interesting to see if it hardens up at 880. Alright, well, let's have a look at it. So that was coming up to temperature to 880 degrees C. Probably took about an hour and a half to reach temperature. and you can see the temperature has done a lot less damage at that lower temperature. Although I have used stainless steel screws, so that they've resisted oxidization pretty well. But the box itself looks like it hasn't got that big layer of oxidization around the outside. I guess once you get up above 900 degrees, things start changing rapidly. So it'll be interesting to see whether or not the carbon has penetrated into the parts at that lower temperature. And then I let it soak for about an hour at that temperature, and then just turned the oven off and let it cool down for several hours. So that's, maybe an hour or so of carburizing, depending on whether or not it reached full temperature inside the box, inside the carbon. So it's a borderline situation. Whoa, that's stuck on. It's going to have to get a little... So this time it's a definite borderline situation. I'm doing that deliberately because the only way I'm going to know is if I go a bit on the light side and see whether it's still carburizing okay. So these are just mild steel threaded rod and a few hexagon extender nuts, and I'll heat these up now and quench them into oil and see whether they've gone hard. So this is basically a full set there. I made this set back in the 70s when I was just starting my own little contract tool making business, and these sort of things weren't available then from China as far as I can remember, and so we were sort of having to make everything ourselves. Alright, 800 degrees C, let's get one of those, quench it into canola oil, and see if it's gone hard. Well, I know it's gone hard because I've just done some, and this is just simulating the procedure for you. I've just tested it on a basket of bits, and I'll just show you. Okay, so here we go. So this is one that I haven't yet quenched, heated up or quenched, and you listen to the file biting into it. It's cutting into it and cutting a flat. Now this is the one I've just quenched. Hard, the file's just skidding over it. So we've got at least 60 Rockwell C there. That's fantastic. That's only an hour in the chips and quenched into oil. It was pretty borderline. I didn't know if it would work, but it has. Hardness testing with a file is easy to get wrong, so I double checked it with my well-proven Starrett center punch method. So sharpen up my Starrett center punch, give it a thump, and then have a look at two things: the condition of the point. See how it's got a flat on it? These center punches are, something like 55 Rockwell C. So it's hard if that happens. And then look at the dent in there. There's no dent at all, is there? Just a little bright circle. Okay, now I want to test the depth of the case. It's supposed to penetrate at about 0.1 or 4 thou per hour. So it should only be about 4 thou, 0.1 deep. This is a soft threaded rod that's not been hardened, and I can scratch it really easily with a scriber. So that'll do for my test. And here's one that's been hardened. Just skids over the surface. so I can measure the overall length, zero it on my digital caliper, and grind off a portion, and then repeatedly test it to see at what point it becomes soft. Alright, we're 0.25 down now, 0.25 shorter. So let's see if it's hard still. Nope, that's still hard. Okay, so now we've ground off 0.5 millimeter, 20 thou off. See if it's soft in the middle. Yeah, that's definitely starting to scratch, but it won't scratch around the edges. Wow, that's so interesting. So it's definitely a very low carbon steel because it is soft in the middle now. I've gone down 0.5 millimeter or 20 thou. Well, that's fantastic news. So that proved that the threaded rod is a very low carbon steel because it's soft in the middle once I get down to a depth of about 0.5 millimeter or 20 thou. So that's incredibly successful. So just using a bit of washing soda crystals and some hardwood charcoal and heating it up for only at temperature for about an hour, it's penetrating in over 10 thou, 0.25 of a millimeter, and just so quickly and effectively that I'm just really impressed with the process, and I'll be using it a lot more in the future, and I'm pleased to be able to pass it on to you guys. Thanks for watching this video through to the end. Keep an eye out for a sister video on a similar subject about how you can through harden mild steel. Now this is something I didn't realize before. I stumbled onto it, and I've tested hardening these mild steel folder blades or fingers, and there's a way to through harden them that's very easy. So keep an eye out for that video. Thanks for watching, guys. Don't forget to like, and if you haven't subscribed, consider doing that if you found something useful in this video. Stay tuned for the next video.